Today we'll be simplifying the greatest common monomial factor and the greatest common binomial factors out of expressions. We'll be working with numbers, which we're familiar with, but let's talk about the variables for a moment. To find the greatest common factor of a variable, if I have x to the fourth, x to the third, and x to the second, what can I divide evenly into all of those variables? The answer will always be the smallest exponent, because x squared goes evenly into x squared, it goes evenly in x to the third, and it goes evenly in x to the fourth because we subtract the exponents. If I were to divide x to the squared out of each of these terms, I would end up with x squared, x, and a 1. So the greatest common factor of x to the fifth, x to the seventh, and x to the fourth is x to the fourth, because I can divide x to the fourth evenly into each term here. So what if the greatest common factor here is x to the seventh, but what if I didn't pick that? What if I picked x to the 10th? What would happen? Well, I would be left here with 1 over x to the third. So that isn't a rational number. Here we have x squared and x to the 1. So you always want to choose the smallest exponent as the greatest common factor when dealing with variables. So let's factor out some monomials. 9x plus 12 divided by 3. Really what that means is 9x divided by 3 plus 12 divided by 3. It's a shorthand form for this. But think of it, each term is going to be divided by 3. So that's going to leave me 3x plus 4. All right, try number 2. Try number 3. Now we're going to factor each polynomial. We're going to find out the greatest number we can pull out and the greatest variable we can pull out. So we're going to factor. So we have 15 and 10. What are the greatest common factor of 15 and 10? Well, 5. So if I factor out of 5, I have 15j, I factored out of 5, so that left me with a 3j. So I'm pretty much dividing by the factor. So minus 10 minus 5 is minus 2. Now I can always check this by distributing, and I should end up with what I started with. Go ahead and try number 6. All right, for number 6, 3 and 8 do not have a common factor. K squared and K do. I can divide a k into each of those. Remember, the variable with the smallest exponent. So I can factor out a k. Try the next one. So the greatest common factor of 16 and negative 24 is 8. E to the 3, e squared. Well, e squared divides evenly into both of those. So if I had 16e to the third and I divided it by 8e squared, that would leave me 2e. A negative 24 divided by 8 is a negative 3. And again, I can check by distributing. Here we have a trinomial. Go ahead and find the greatest common factor. So I know 2 will divide evenly into each number. I have an r to the 5th, r to the 4th, but no variable here, so there's no common variable. So just 2. Now let's look at the common binomial factor. Take it up a notch. So factor out each expression. So here I have the expression 6x times the quantity x plus 9 minus (4x plus 9). So those are two different expressions. So what can I factor out? What do they have in common? They have an x plus 9 in common, here and here. So I can factor out x plus 9. And that would leave me 6x minus 4. Try number 10. And I can factor out f plus 3 because there's one in this term and there's one in this term. So I can factor that out. F plus 3. And that leaves me 7f minus 2. Try number 11. And try number 12. Alright, so we just factored out the greatest common factor there. Now that's going to help us factor these 4-term polynomials. So what we're going to do first is we're going to group these two terms, and we're going to group these two terms, and we're find the greatest common factor of 3 and 12 is 3, and of y to the 3 and y squared is y squared. And the greatest common factor of 2 and negative 8 is a 2. Okay. Now, can we factor out? We have this term and this term. Can we factor out a common factor? Yes, y minus 4. And that leaves me the other factor of 3y squared plus 2. Go ahead and try 14.